Hi students, this video is going to help you figure out some of the properties of dot product. Um, when you're multiplying two vectors, there are two types of product, that is dot product and cross product. I'm going to cover up cross product later. So dot product is going to be the major objective of this video. So first of all, the ideal definition is when you are multiplying two vectors which are, let's say, at certain angle, which are making theta. We define the dot product. Standard definition is A dot B is going to be magnitude of A, magnitude of B times cos theta. Also, there is another definition, which is consider that vector A has the direction as x1, y1, z1, x2, y2, and z2. Vector A dot B is going to be x1, x2, y1, y2, and z1, z2. Uh, so if you you just make cos theta the subject from here, which becomes as A dot B or magnitude of A times magnitude of B. This is one of the very useful outcomes to figure out the direction between two vectors, between vectors. So this is going to be a really important result. So throughout the whole vector chapter, you're going to use this again and again. So make sure you're crystal clear with this one. Going ahead with this one, consider that if there are two vectors which are perpendicular to each other, so of course out here is going to be 0 because cos 90 is going to be 0. So if you cross multiply this, you're going to get A dot B as 0. So for perpendicular vectors, you have A dot B as 0. So if you take dot product of the directions and multiply out, and if it comes to 0, you consider those vectors as perpendicular vectors. So one of the simple example is consider the three-dimension notation which we use in our generally in the planes and space study. If you have, let's say, I representing a vector along x-axis, this is a unit vector. A unit vector is just a vector with another with magnitude as 1, and j is the unit vector along y, and k is the unit vector along z. So this is x, y, and z axis basically, and I represent a vector which is having a length of 1 along x-axis. So if you consider them, the property is I dot j is going to be 0, j dot k is going to be 0, k dot I is going to be 0. So if the vectors are perpendicular, remember that the dot product must be 0. Also, when vector is either parallel or collinear, or it's the same vector, if I'm taking dot product of the same vector, it's going to be just the magnitude square. The reason is that if I consider the vector A, the angle between the vector is going to be 0. So if I use the definition A dot B, if my vector B is also same as vector A, so here is going to be 0 and here is going to be A. So your vector becomes magnitude of A square, which is very, very easy to understand. So coming to the applications of this, again, this is one of the very important outcome. So I would say remember this outcome because this is frequently assessed in Math HL examination. Coming to some of the applications of this, let us say if the question is that it's given to you, if it's given, this is given to you, and you want to find out what can you say about vector A and B. So starting with your answer part, a lot of times students get confused because they don't have any idea about how to go ahead about that. Now just one step, remember that we did magnitude of A square is A dot A, which is going to be, if you consider squaring both the sides, because A dot A is going to be magnitude of A square. So A minus B can be written twice. It's similarly with A plus B. Now if you expand both the brackets, so A dot A is magnitude of A square. So if you consider this property, you're going to get this expansion left hand side and this expansion right hand side. Now because it's a magnitude, it's going to get cancelled. It's just a normal scalar number. This is going to get cancelled, but do not cancel these two terms because these two are going to be your main calculations to proceed. So this is going to be 4 dot A dot B is going to be 0 because if you bring 2 this side, it's going to be 4 A dot B 0. Dividing this side 4, you get A dot B as 0. If your A dot B is 0, you consider the vector to be perpendicular. So that's what we got. So generally a lot of times this kind of questions are assessed. Giving you another example of this identity, let us say proving cosine rule using vectors. So you must be knowing what's cosine rule. Generally, we study in IGCSE that it's gonna be if you have a square, it's b square plus c square minus 2bc cos a. So this is the general definition that we learned in IGCSE. It's a little different than the notations I'm using here. Remember, these are not the same notation as this one. So just this for reference purpose. So this is just for reference. So coming to what exactly I can do is, so I took a triangle, I drew the triangle, I took three vectors, BA, BC, and AC. Clearly, if you look at the vector geometry, your vector C is going to be minus A plus B. I mean, minus B plus A, that's what I got. So if I square C dot C, it means that I'm trying to take, it's just actually squaring both the sides. So you get this. So magnitude C dot C, you know, is magnitude of C. And if you open it up, you're going to get this as the previous example. Because A dot A is going to be magnitude of A dot B minus B dot A, and plus B dot B, which is going to be this. And twice A dot A being both negative gives you this term. So your standard definition is going to be now for applied out here. So A dot A B is going to be magnitude of A, magnitude of B into cos theta. So clearly you can see that this is your cosine rule. So C square is A square plus B square minus 2AB cos theta. Alright, giving you another example of the same property, A dot A being magnitude of A square. There was another examination question, so this is another past paper question I've taken. So it's A dot A plus 2B, magnitude is B minus 2A magnitude. What can you say about A and B given that A and B are unit vectors? So first of all, if you have a unit vector clearly means that magnitude is going to be 1. So again, you square both the sides and you expand the same way I did the previous examples. So you're going to get A dot A is going to be magnitude of A square, and so on so forth. Also, you know that magnitude of A, magnitude of B all being 1, you're going to get finally A dot B as 0. If you want to pause this video and reflect back, you can do that. Or else, if you're understanding, proceed to the next example. Because A dot B is 0, it clearly means that two vectors that are given out here are perpendicular. Another example is that this is a very common example, proving an angle in a semicircle being a right angle. See, generally they give you certain data out here. So if you have, let's say, vector OA given to you, this is a semicircle, all right, and they have given vector OB as B, vector OA as A. You have to prove that angle ABC is a right angle. All right, this is the objective. So I have to prove that this is a right angle out here. So for this, if I could prove that your vector AB dot product with vector BC, if it is 0, then my job is done. So you do one thing is you figure out vector AB first. So I first find vector AB in terms of B and A. So vector AB is going to be negative A, positive B. So negative A, positive B. Vector BC is going to be B to O and then O to C. Now if you remember this, it's just opposite vectors. So that's why I'm taking vector negative A, because this side it's positive A. And being the radius, its magnitude is going to be the same. Now negative B, negative A. So what I am doing is I'm trying to take the dot product of these two vectors and prove that it's going to be 0. So you take the same vectors, their values I'm going to put here, and this is the value of the other one. Expand it the way I did other examples. You, in case if you're not clear with this, reflect back. Now this gets cancelled, if you clearly see, and this is your magnitude of A square minus magnitude of B square. Now if you look at magnitude of A, it's just the radius. Magnitude of B is again the radius. So radius square minus radius square is going to be 0. So because your dot product is 0, hence the vectors are perpendicular. Going to the next example. This is one of the examples of other ones. So hope this video helped you.